Hello everyone, welcome to SANGAM tutorials, Gubbi online classes for NCERT 10th standard and CBSE 10th standard for mathematics and science. So in the last session of polynomials we had discussed the algorithm of division for polynomials and we had solved many problems on it. So some 4 to 5 problems were done in the last session. So in today's session we will continue the problems on that is division algorithm for polynomials. So very important problems we are going to come across today in today's session. So practice the problems and take a grip on the subject. Right. So check whether the first polynomial is a factor of the second polynomial. So in the sense you will be given two polynomials now, which first one is one of the polynomial is called the first polynomial and another one is the second polynomial. So whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So we have to divide the first polynomial by that is the second polynomial by the first polynomial and check whether the first polynomial is a factor of the second. So when we divide the second polynomial by the first polynomial and how to check whether the first polynomial is a factor of second, the simple criteria is when you divide the second polynomial by the first polynomial, the remainder what you get should be equal to 0. So these things I had already discussed in the previous sessions. So once again I will tell you, if the first polynomial has to become the factor of the second polynomial, then when we divide the second polynomial by the first polynomial, the remainder we should get equal to 0. So if it is not equal to 0, so what is our conclusion? So it's very simple. When you divide the second polynomial by the first polynomial, if you do not get 0 as the remainder, so it is understood that the first polynomial is not a factor of the second polynomial. It is that simple, right? So we'll go with the first problem here. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first. So here this is the first polynomial and this is the second polynomial. We will write it. So first polynomial is let it be g of x is equal to t square minus 3 and second polynomial. And second polynomial is, let us give a name to that. So p of x is equal to 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. So we have to write the first and the second polynomials as per the question. So now we will carry the division process. We will start it. So in yesterday's session we had discussed how to divide a given polynomial by the other polynomial. So here before the division is going to start, we have to check whether the polynomials are in the standard form or not. So please check it out. So here t square minus 3 is in the standard form and 2t to the power 4, t cube, t square, t to the power 1 and constant. So that is also in the standard form. So we can start the process. So this is t square minus 3 and the polynomial is 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. So this is the given polynomial. Let us start the process. So t square into what gives you 2t to the power 4. So it is 2t square. T square into 2t square is 2t to the power 4 minus 3 into 2t square is minus 3 2s are 6t square. So you have to subtract this from this. So therefore we will draw a line, we will change the signs. So the first terms cancels. So you have to simplify the like terms here. So when we simplify the like terms, this is t cube and this is t square which is not going to get simplified. So therefore you have to search the like term in the polynomial. So here we have minus 2t square and here we have minus 6t square. So before simplifying this, write the term which is having the highest degree, 3t cube. So then we will simplify these two. So minus, that is plus 6t square minus 2t square is plus 4t square. So let us take these two terms, minus 90 minus 12. So again we will start the process. So t square into what gives you 3t cube. So it is plus 3t. So t square into plus 3t is 3t cube. Minus 3 into plus 3t is 9t. Okay, we will go with the process. You have to subtract this from this. So you have to change the signs. So 3t cube minus 3t cube cancels. Plus 4t square is there. So nothing here to simplify that particular term. So we will write it like how in the same form. So plus 90 minus 90. So both they get cancelled. So you are left over with minus 12. So again we will go with the algorithm. T square into what gives you 4t square. So it is plus 4. T square into plus 4 is plus 4t square. Minus 3 into plus 4 is minus 12. So we have to subtract this from this. Sign changes. Okay. Plus 4t square minus 4t square cancels. Minus 12 plus 12 cancels. And the remainder is 0. So successfully we have got the remainder as 0. So therefore, since you have to write the statement, since remainder is 0, therefore we can call that remainder as r of x. So r of x is equal to 0. So therefore we have divided this polynomial by this polynomial. So therefore we have got the remainder as 0. So therefore this polynomial is a factor of this. So therefore t square minus 3 is a factor of that is 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. So this is how you have to present the problem. So it is very important, right? Very important. So this is the procedure you have to follow, and just getting the remainder and not writing anything here shows that you have not understood the problem, because you have to write the conclusion of the problem, and we have to verify that is t square minus 3 is a factor of this. So this is very important. Okay, we go to the next problem. Right, we'll go with the second problem now. Same question, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first. Okay, x square plus 3x plus 1 is one of the polynomial. So using this you have to divide 3x to the power 4 plus 5x cube minus 7x square plus 2x plus 2. So these are the two polynomials given to you. So you have to check whether this polynomial is a factor of this or not. So simple procedure is, when you divide this polynomial by this, if you get the remainder 0, then this is a factor of this. If you do not get the remainder as 0, then this is not a factor of this. So very simple. First polynomial is, that is x square plus 3x plus 1, and second polynomial is, this is given, that is 3x to the power 4 plus 5x cube minus 7x square plus 2x plus 2. Okay, so now we will start the process of division by the steps of algorithm. We will follow the algorithm. So this is the division process. So x square plus 3x plus 1 and 3x to the power 4 plus 5x cube minus 7x square plus 2x plus 2. So this is the given polynomial, right? So we'll start the process here. X square into what gives you 3x to the power 4? So it is 3x square. X square into 3x square is 3x to the power 4. So we can write it here. Plus 3x into plus 3x square becomes 3 3s are, it is 9. X into x square is x cube. Plus 1 into 3x square is plus 3x square. So we have to subtract this from this. So sign changes. Okay, 3x to the power 4 minus 3x to the power 4 cancels. Plus 5x cube minus 9x cube is minus 4x cube minus 3x square minus 7x square is minus 10x square. So we will take the two terms below. So plus 2x plus 2. So these are the things. So this is the remainder what we have got. So here you can see the degree of the remainder is more than the degree of the divisor. So therefore we can continue the process of division. So x square into what gives you minus 4x cube. So it is minus 4x. X square into minus 4x is minus 4x cube plus 3x into minus 4x is minus 12x square plus 1 into minus 4x is minus 4x. So we will subtract this from this. So sign changes. So very simple. So minus 4x cube plus 4x cube cancels. Minus 10x square plus 12x square is 2x square plus 4x plus 2x is plus 6x and plus 2 we will write, we will carry that. So again x square into what gives you 2x square, so it is plus 2. X square into plus 2 is 2x square plus 3x into plus 2 is plus 6x plus 1 into plus 2 is plus 2. So very simple, we will subtract this from this. So therefore sign changes. Right, plus 2x square minus 2x square cancels, plus 6x minus 6x cancels, plus 2 minus 2 cancels, so therefore remainder is 0. So successfully when we divide this polynomial by this, we have got the remainder as 0. So since we have to write the conclusion, since remainder is 0, so therefore x square plus 3x plus 1 is a factor of 3x to the power 4 plus 5x cube minus 7x square plus 2x plus 2. So this is how we have to conclude. So this is a very important problem, right? So while division you have to be very careful with the signs and the carryover what you take. Right, be careful. So we'll go with the next problem. Right. So first polynomial we will take, that is x square minus 3x plus 1. And second polynomial will take x to the power 5 minus 4x cube plus x square plus 3x plus 1 plus x square plus 3x plus 1. So here two polynomials have been given to you. This is the first polynomial, this is the second polynomial. We have to divide this polynomial by this and check whether this is a factor of this. So very simple criteria, when we divide this polynomial by this polynomial, if you get the remainder as 0, then this is a factor of this. If you do not get, then it is not a factor. Okay. So we write the first polynomial and second polynomial. First polynomial is x square minus 3x plus 1, and second polynomial is x to the power 5 minus 4x cube plus x square plus 3x plus 1. Okay, so we'll start the division process. It's very simple. Right. So it is x square minus 3x plus 1. So this is the polynomial given, first polynomial. We will write the second polynomial, x to the power 5 minus 4x cube plus x square plus 3x plus 1. So this is the second polynomial. Now we will start with the division process. Now x square into what gives you x to the power 5. So it is x cube. X square into x cube is x to the power 5. So here x square into x cube is x to the power 5, because x to the power, when the bases are same, powers can be added. That that is 2 plus 3, so that becomes x to the power 5. So this is how you have to imagine. Okay, x square into x cube is x to the power 5, minus 3x into x cube is minus 3x to the power 4, plus 1 into x cube is plus x cube. So we will start the process. It's minus, it's plus, and it's minus. So first terms cancel. So here we have plus 3x to the power 4. Here we have minus 4x cube. So x to the power 4, x to the power 3. So they are not like terms. So therefore we are going to go with the simplification of like terms here. So for 3x to the power 4, no term is there for the process of simplification. So therefore we will write the term as it is, 3x to the power 4. So now we will simplify the like terms. So minus 1x cube minus 4x cube is minus 5x cube plus x square plus 3x plus 1. So this is the process. So we will continue. X square into what gives you 3x to the power 4. So it is plus 3x square. X square into plus 3x square is 3x to the power 4. Minus 3x into plus 3x square is minus 9x cube. Plus 1 into plus 3x square is plus 3x square. So we will do the process. We will change the signs. Right. So first terms cancels. So plus 9x cube minus 5x cube is 4x cube, and minus 3x square plus 1x square is minus 2x square plus this term, that is 3x plus 1. So now x square into what gives you 4x cube. So it is x square into plus 4x gives you 4x cube. So x square into plus 4x is 4x cube. Minus 3x into plus 4x is minus 12x square. Plus 1 into plus 4x is plus 4x. So we will subtract this. So minus, it is plus, it is minus. So first terms cancel. So plus 12x square minus 2x square is 10x square. Minus 4x plus 3x is minus x, and plus 1 carries. So still the process of division continues. So x square into what gives you 10x square. So that is plus 10. X square into plus 10 is 10x square. Minus 3x into plus 10 is that is minus 30x. Plus 1 into plus 10 is plus 10. So we will change the sign. This becomes minus, and this is plus, and this is minus. So plus 10x square minus 10x square cancels. So here plus 30x minus 1x, that becomes 29x. Minus 10 plus 1 is minus 9. So now the division process stops here. Why? Because here the degree of the divisor is 2 and the degree of the remainder is 1. So we cannot further carry the process of division. So when I divided this polynomial by this polynomial, I am not getting the remainder as 0. So when I do not get the remainder as 0, I can come to a conclusion that this is not a factor of this. So that should be written as a conclusion. So since remainder is not 0, so therefore x square minus 3x plus 1, right, is not a factor of x to the power 5 minus 4x cube plus x square plus 3x plus 1. So this is the final conclusion. So this is a very important problem because 4 steps are involved. 1, 2, 3 and 4 steps are involved in the algorithm. So therefore we have to practice this well. We go with the next problem. Right. So here the problem changes. obtain all zeros. Obtain all zeros of 3x to the power 4, that's a polynomial, plus 6x cube minus 2x square minus 10x minus 5. So this is the given polynomial, plus 6x cube minus 2x square minus 10x minus 5. Obtain all the zeros of this polynomial if 2 of its zeros are, if 2 of its zeros are square root of 5 by 3 and, very important problem, square root of minus 5 by 3. Okay, so this problem will be for 3 marks. Compulsory, this problem will be given for 3 marks. You have to observe very well, you have to understand the problem, understand the theoretical background behind that, a little bit of imagination is required here. Right, so we go with that. Obtain all the zeros of a polynomial is given of degree 4. So you can see the polynomial here, 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. So now, for this polynomial, that is, let us take a name for this. Let p of x is equal to 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. So this is the given polynomial of degree 4. So if a polynomial has degree 4, then it has at most 4 zeros. At most it has 4 zeros. So it can also have 3 zeros, it can also have 2 zeros, it can also have 1 zero, it can also have no zeros. So here in this case, obtain all the zeros. In the sense, this polynomial p of x has 4 zeros. It has 4 zeros. Out of those 4 zeros, 2 zeros are given to you. That is root 5 by 3 and minus root 5 by 3 are the 2 zeros given to you. So these are the 2 zeros of this polynomial. So using this, we have to find out the other 2 zeros, other 2 remaining zeros. I hope you understood the problem. This is the given polynomial. So it's a polynomial of degree 4. So we know that a polynomial of degree 4 has 4 zeros. So out of those 4 zeros, 2 zeros are given. That is, one is root 5 by 3 here and another is minus root 5 by 3. So using this, you have to find the remaining 2 zeros. Remaining 2 zeros we have to find. Okay. So this is one of the 0. This is one of the 0. So 2 zeros are root 5 by 3 and minus root 5 by 3. So these are the 2 zeros. So now, as x is the variable involved in the polynomial, let us equate both the zeros to x. So therefore, x is equal to root 5 by 3 and x is equal to minus root 5 by 3. Right. So we'll take it inside. So x minus root 5 by 3, right, will be equal to 0, and here x plus root 5 by 3, because it has minus root 5 by 3. When it comes inside, that is to the LHS, when it gets transposed, its sign changes from minus to plus, which is equal to 0. Right. So this is a binomial, this is a binomial. So this binomial is equal to 0, this binomial is also equal to 0. So therefore, the product of these two will be always also equal to 0. So x minus root 5 by 3, you can write it like this, x minus root 5 by 3, right, into x plus root 5 by 3 is equal to 0. Right. So this is in the form of a plus b into a minus b. So this can be written as x whole square minus root 5 by 3 whole square, which is equal to 0. Right. So x whole square is x square minus root 5 by 3 whole square is the square and the root symbol cancels. So we are left over with just 5 by 3, which is equal to 0. Let us take LCM for this. So LCM for 1 and 3 is 3. X square by 1 into 3 is 3x square minus 5 by 3 into 3 is 5, which is equal to 0 by 1. So let us go with cross multiplication. So 3x square minus 5 into 1 is 3x square minus 5, and 3 into 0 is 0. So therefore, let us take 3x square minus 5, the polynomial what we have got here, as g of x. We will consider that as g of x. So therefore, g of x is equal to 3x square minus 5. So now, what all the things happen now? So we did very simple things. A polynomial was given. This polynomial has two zeros. I took those two zeros and I equated that to x because they are zeros. The x is equal to root 5 by 3 and x is equal to minus root 5 by 3. I took it inside, so they are equated to 0. I solved it, and at last I have got that is the polynomial g of x is 3x square minus 5. So what is to be done next? So here we have p of x. So here we have p of x with us. So here we will divide this p of x by this g of x. We will divide this p of x by g of x. Then when we divide this p of x by g of x, we get a quotient. When we get a quotient here, when inside that quotient what we get when we divide p of x by g of x, we get a quotient. Inside that quotient we will be having the remaining two zeros. So what is the procedure here? If a polynomial is given and the two zeros are given, and if you are asked to find out the other two zeros, very simple. What the two zeros you have been given, equate those two zeros to 0 and go on solving it. What I have done like this here, you will get an expression or a polynomial. When we divide this polynomial by this another polynomial what we have got, because of those two zeros we get a quotient. When we open that quotient by factorization process, we are going to get the other two zeros. So this is the procedure. Keep it in your mind. So now, so to obtain other two zeros, divide p of x by g of x. Let us divide this. So let us go with the division process. So let us write the polynomial, that is 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 is the polynomial. So our g of x is 3x square minus 5. So let us start the process of division. So 3x square into what gives you 3x to the power 4? So it is x square. 3x square into x square is 3x to the power 4 minus 5 into x square is minus 5x square. So let us subtract this, change this sign, this is plus, these two gets cancelled, plus 6x cube plus 5x square are one below the other, but we cannot simplify that because they are not like terms. So 6x cube, we will take it here, plus 5x square minus 2x square is plus, okay, 5 plus 2 is, 5 minus 2 is 3x square, that is plus 5x square minus 2x square is plus 3x square minus 10x minus 5. It continues. So 3x square into what gives you 6x cube. So it is just 2x. 3x square into 2x is 6x cube minus 5 into plus 2x is minus 10x. So let us simplify this. This is minus and this is plus. It gets cancelled. So here for plus 3x square, no term is in the bottom to get simplified. So we will carry the same step, that is 3x square plus 10x minus 10x, they are going to get cancelled. So remaining is minus 5. So 3x square into 1 is 3x square minus 5 into plus 1 is minus 5. So sign changes, so terms gets cancelled, so remainder is 0. So compulsory we have got the remainder as 0. Here look at the quotient. So when we divide this polynomial by this combination of two zeros, that is 3x square minus 5, we have got this quotient. So inside this quotient, which is a quadratic polynomial, the two zeros are hidden inside it. So to take out those two zeros, we have to factorize this by the sum and product method. So let us do it. So x square plus 2x plus 1. So we will equate this to 0, so that because we are obtaining the zeros of the polynomial, we will equate that to 0. So x square into 1 is x square. We have to split this into two numbers, that is 1x and 1x. Very simple. So x square plus 1x plus 1x plus 1 is equal to 0. That is plus 1x and plus 1x. So from here and here we can take out common. X into x plus 1 plus 1 into x plus 1 is equal to 0. We will take out common from these two terms. That is x plus 1 is the common because we have in both the terms. So remaining is x plus 1 again, which is equal to 0. This into this is equal to 0 is x plus 1 is equal to 0, and again x plus 1 is equal to 0. So x is equal to minus 1 and x is equal to minus 1. So these are the two zeros. So ultimately we have four zeros here, two zeros from the data, that is root 5 by 3 and minus root 5 by 3, and the other two zeros are minus 1 and minus 1. So therefore the other two zeros, are minus 1 and minus 1. So therefore totally there are four zeros, root 5 by 3 and minus root 5 by 3, two zeros, minus 1 and minus 1, other two zeros. So totally there are four zeros for this polynomial. So in most of the examinations for SSLC, that is state syllabus, this question was asked for 3 marks. In the preparatory exams also I have seen this. So it is being asked for 3 marks. So the similar problem is in your worked examples in your textbook. So please solve it as a homework. Right. So now we will go with the fifth problem, very important, very important, which can be asked for 2 marks, very important. So I will we'll go with the problem. So on dividing a polynomial is given. So x cube minus 3x square, that is the polynomial, plus x plus 2. On dividing this polynomial by another polynomial, by g of x, another polynomial by name g of x, quotient is x minus 2. Quotient is x minus 2. The quotient what we have got is x minus 2, and remainder is minus 2x plus 4. The remainder what we have got is minus 2x plus 4. So find g of x. We have to find g of x. So this is for 2 marks, very important. Okay. On dividing, this polynomial is there, so let p of x is equal to x cube minus 3x square plus x plus 2. This is the given polynomial. Quotient is q of x is equal to x minus 2, and the remainder what you have got is minus 2x plus 4, that is r of x is equal to minus 2x plus 4. So you have to find g of x. So clearly it is nothing but the division algorithm for division algorithm for polynomials. Okay, so using division algorithm for polynomials, we have to solve this. So in the next session, I will be showing you how we go with this problem. Right. I hope you enjoyed the entire session. Right. Keep learning. Stay home. Stay safe. Thank you.